moving along, just like circles, ellipses have a standard form. When we had circles, the standard form had an x squared and a y squared on one side, and then an r squared on the other. This will be very similar to that. So, what we're going to start out with is the same thing that we started out with circles, which is we're going to start out with our center. And how do we find our center? Well, just like with circles, your center is going to be determined by what's sitting along inside with your x in the squared term and what's sitting along with the y in its squared term. But remember, just like with circles, it's actually opposite of what you see. So if you see a negative, that means you're actually going to move to the right if it's with the x's. If it's a negative with the y's, you're going to, again, do the reverse. You're going to go up. So you always use the reverse of what you see with your signs. So that's what's going to make up your center and how you're going to shift your graph left or right. Okay, notice another thing that's different with ellipses is notice that we equal 1 instead of a radius squared. We can't equal a radius squared because guess what? You don't go left and right the same amount as you do up and down. So you have one radius for your x's and one radius for your y's. How much you're going left or right or how much you're going up or down. So the difference with ellipses is we want a 1 on the other side. We want to keep two different numbers under our x squared and our y squared. Whatever number is going to be under our x squared is going to be, and I don't always like this terminology, but I always end up calling it Rx. It's kind of like your radius for your x's. It tells you how much you're going to be going left and right from the center. And whatever number is going to be underneath your other one, again, be careful, it's already squared, just like the last one, is going to make up your radius for your y's, whatever you're going to move up or down. But be careful on both of these. It is already squared, just like it is on the equation for circles, the radius was squared. So, whatever's underneath the x's, it's already squared, will give us a hint as to what the radius is, so it will tell us how much to go out left and right to form our ellipse. And whatever's underneath our y squared is what's going to be our radius squared for the y's, will show us what we need to move up and down from the center to, again, form our ellipse. Okay, how do I find the foci? Well, and the vertices. Well, the vertices, what are the vertices? The vertices are always the ends of the ellipse on the major axis. In this first example, or this first general example, we're looking at the major axis, the longest axis being the x's. But it won't always be like this. So the vertices, whenever they talk about vertices, are always the endpoints of the major axis, the axis that's the longest. So vertices, it's the points at ends of major axis on your ellipse. Okay. Also, your foci, notice, are also always on your major axis of your ellipse. Notice, though, that they land inside of your ellipse. Here they are. So how do you find your foci? Well, you basically take the center and you add and subtract something to the x-axis on these, and the only reason why you're adding them and subtracting them on the x-axis is because you're on the major axis, is because right here, major axis, our longest axis on this one, is the x-axis, your left and right. So you'll take your center value and the y value will stay the same, but your x value will add and subtract a value c. How do you find c? Well, for ellipses, this will not change. It'll be that it's c squared equals a squared minus b squared. So it looks almost like Pythagorean theorem. It's just a little bit off. It has a minus instead of a plus in between your a squared and your b squared. Be careful. We are not allowed to give you a formula sheet on your tests or your final exam. So you do have to remember that with ellipses, you have something that looks like the Pythagorean theorem, but is not. C squared equals a squared minus b squared. So most of your homework problems will ask you, you'll need to find a center, the vertices, the foci. You might also need to find the domain and range, all sorts of things. Continuing along, let's look at the other example when the major axis is the y-axis. Notice the center is still found the same way. The center is still found by looking at what's along with your x squared and what's along with your y squared. And again, you always do the opposite of what sign is actually listed. Notice, though, in this particular one, the y-axis is the going up and down is going to be your major axis. That's why we're saying that A is bigger than B here, means that this number will end up being bigger or longer. That means that your radius here for your y values, which just like before is already squared, is the longest. Your radius for your x values on the other side, and it's already, again, just like before with the other ellipse squared, so nothing really changes. Notice you are still going to have to find vertices and foci, but again, they're going to be going up and down this time. So this time, your x's should stay the same, because you're not going left and right. Your y's should be what's changing. So let's look at your y's here. Well, you start at your center, which is your y value of, in this one, whatever's with your y's, which we're calling that k here. And to find the vertices is the easy one. You're going to take whatever your radius is for the y's, and that's going to be what creates your ellipse and has you going up and down, and those are the endpoints, your vertices anyways. So your vertices are the ends of your ellipse here, and again, that's just going to be based on whatever your radius is, whatever you're going up and down from the center to create your ellipse. That's why you see them using the A here in the formula. The other one, just like all other foci, is going to have to deal with, you have to find that C value, which is almost the Pythagorean theorem. It's c squared equals a squared minus b squared again. It doesn't change. The only difference is not the formula, is that, again, your foci have to deal with y values. So when you find your c, you're going to add and subtract it to your y value from the center. You're not touching the x's this time. You're only affecting the y's. So, in summary, what's going to determine what the major or the minor axis are on ellipses is which denominator is bigger. If the denominator on the x's is bigger, then what we're going to have is that our major axis is going to be along the x's is going to be largest going left and right. That will be your major axis. If the denominator is bigger on the y's, then your radius will be bigger on the y's and you'll go up and down more. So that will be your major axis. It just depends on the problem and which denominator is bigger. But foci, no matter what, are always going to be on the major axis. So you're always going to add or subtract C. So you're always going to add or subtract C. The question is to what? The X's or the Y's, and it depends on which one's your major axis. The X's, are you looking at left and right, or are you looking at the Y's, up and down? And no matter what, your C is going to be found by using C squared equals A squared, close to the Pythagorean theorem, not quite, minus B squared. That's our formula we're going to use.